Hello again on Level Geniuses. We're back for round 2 of more chemical compound naming and writing. So for today's bell work, how many protons, neutrons, and electrons are in this atom? So as we see from the little key here that the protons are in red, so we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 protons. And count your yellow neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 neutrons as well. So we've got 12 protons. I make that plus sign better. 12 neutrons. And if we count our electrons, we've got 2, 4, 6, 8, 10, 11. 11 electrons. Okay, so based on what you know about the charges of a proton and an electron, what is the overall charge of this atom? Well, if we have 12 positives and 11 negatives, that would mean that my overall charge for this atom is a +1 or a 1+. And based on what we know about protons, we can determine what element this atom is representing. So if I look that I have 12 protons tells me the atomic number is number 12. And I look at my bestie, my periodic table, and I see that magnesium is atomic number 12. Okay, so we've seen in the past ions when we were talking about periodic trends and ion size and ion radius. But we need to make sure we understand what an ion is, okay? And we basically saw that in our bell work just now. An ion is an atom or a group of atoms, because we can have polyatomic ions, but we'll get to that later. But basically, for right now, we need to understand that it is an atom that has a charge. And it has a charge because it has either lost or gained electrons. We don't ever change proton numbers per element, but we can easily lose and gain electrons. And when we do that, we no longer have the same number of protons and electrons. So one of them will outnumber the other, giving us either a positive charge or a negative charge. So let's look at our example. When we look at sodium, we see that sodium has 11 protons. And then chlorine here, so 11 protons, and chlorine here has 17 protons. All right, so remember, elements always are trying to get to noble gas status. In order to do that, they will lose or gain electrons to have 8 valence electrons. That is 8 electrons in its outermost energy level. So sodium and chlorine make a really nice pair here because sodium has that one little electron out here in its outer energy level that it is just wanting to get rid of. It's so tired of it. Let me get rid of this. I will give it away for free. All right. And chlorine is over here having 7 valence electrons. And it's like, please, 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 I just need one more. Help me out. So they make this deal. And sodium decides to just give right here. It's donating its 1 electron over here to chlorine, who is accepting. So when this happens, now sodium, still having 11 protons, will only have 10 electrons because it gave 1 away. So its overall charge will be a +1. And chlorine, still having 17 protons, has now taken in an extra electron, so it has 18 electrons, will have an overall charge of 1-. So see how they lost or gained, depending on which atom we're looking at, an electron, and it has given us a different number of electrons than we have protons, so we will have some sort of charge. Sodium a +1, chlorine a -1. Okay, so let's practice. Yay! And here's the thing. We don't really even need to know their atomic numbers at this point. We just need to look at how many electrons they're losing or gaining here. So if sodium loses an electron, That means it's losing 1. So now its protons are outnumbering its electrons by 1. So we have 1 more proton, which means we have a 1 plus charge. Okay? Magnesium loses 2 electrons. So it's losing 2 electrons. So now its protons outnumber its electrons by 2. So that means we have a 2 plus charge. Chlorine gains 1 electron. Now we're flipping the coin. We're gaining an electron. So now our electrons are outnumbering our protons. So we have more negatives. So we are a 1 minus. Okay? And now phosphorus gains 3 electrons. So now our electrons outnumber the protons by 3. So we have more negative particles by 3 times. So we have a 3 minus charge. Okay, let's move on. All right, so we probably have heard this word before, but it's cation. So an ion that becomes positively charged after it loses its electrons. See right here? Right here. It says that the electrons were lost. When that happens, the protons outnumber the electrons, so therefore we are a positively charged ion. We have a plus sign. Here's the thing. The metals, which you learned are on the left-hand side of the periodic table, left of the staircase, these guys all tend to lose electrons, so they all tend to make cations, all right? So for this reason, we say we are positive about metal cats. All right. And the thing about naming cations when we have an ionic compound is that they just keep their element name. We don't have to do anything to it, which is super easy and super convenient for us and very nice. So we are positive about tiny cats. If you remember or were taught, cations get smaller in size than their neutral atoms. So it's tiny happy cats, or we are positive about metal cats. Now, the flip side of this is the anion, all right? Anions is where we gain electrons. And if we're gaining electrons, then that means the electrons are outnumbering the protons. So we are going to have a negative ion charge. So where the metals became cations, you're right, you figured it out, you brilliant minds. The nonmetals tend to form anions. They tend to gain and take in extra electrons. So we say we feel negatively about ants. And if you go back to anion size, anions are gaining particles, so they are larger. They are larger than their neutral atoms. So we say giant angry ants. Or we can just feel negatively about ants. Either one, whatever floats your boat and lets you remember this. All right, so you heard me mention ionic compounds. Obviously, what we're going to do is we're going to have a cation, a positively charged ion, and an anion, a negatively charged ion, coming together to make a compound. Now, in most cases, like 99.9% of the cases, it's going to be a metal bonding with a nonmetal, okay? So yesterday, if you remember, molecular compounds were 2 or more nonmetals coming together. Well, in ionic compounds, now we see the metals coming into play. We've got a metal bonding with a nonmetal, okay? And what you've got to really realize is that these guys are electrically neutral, which means their charges are going to balance each other out. Some characteristics of ionic compounds that are super important, muy importante, is that the majority of them are solid at room temperature, okay? Let's look, for example, at what we have going on in this box. We've got sodium and chlorine coming together, and we saw this one a couple slides ago in our example as well. This is your classic example of an ionic compound. Now, sodium chloride, as most of you know, is table salt. How many of you have ever tried to melt table salt? That's what I thought. There's a few of you who tried this. How well did that work? Not so well, right? It is going to take tons and tons and tons of heat energy to try to melt table salt. I mean, let's just be real, guys. You're not going to do this in your kitchen, okay? Not going to happen because these solids, table salt is solid at room temperature, which is our characteristic right here of table salt, okay? These guys have really high melting points. More energy than your stove is going to produce for you to melt that salt, okay? So keep that in mind. And here's the other thing. The more positive element comes first, always. So basically all you have to keep in mind is that the metals are always the ones that form your cation ions. So the metals always get written first. I guarantee some of y'all are going to do that backwards at some point in this unit. Don't do it. Don't do it. Write the metals first. Metals always come before nonmetals. Look at our examples here. Sodium chloride again. Sodium is the metal. Chlorine is the nonmetal. Sodium fluoride. Well, hey, look at sodium again. Sodium's the metal. Fluorine is the nonmetal. And then our last example, calcium. Again, calcium's the metal. Chlorine is the nonmetal. So, ionic compounds, solid at room temperature, high melting points, and metals always come first. All right, so time for a little joke here. The little teacher says, perhaps one of you gentlemen would mind telling me just what it is outside the window that you find so attractive. And looky there, all those little girls, those negatively charged anions, the little positive boy and cations are attracted to them because opposite charges attract. Okay, so there are different types of ions. So let's differentiate between them. First, we've got monatomic. Well, what did we learn mono meant yesterday? One, right? So one atom ions. So these guys are going to be representing all the elements on the periodic table. The fun thing for us is that we can look at their position on the periodic table and determine what their charge is going to be. So for example, Group 1 elements will always be losing that one valence electron, so they will always have a +1 charge. Group 2 elements will always be losing 2 electrons, so they'll always have a +2 charge. Group 3 elements will always be losing 3 electrons and have a 3+ charge. And then vice versa, we start flipping. As we hit group 5, they're going to gain 3 electrons, so they're going to have a 3- charge. Group 6 will always gain 2 electrons, so it'll have a 2- charge. Group 7 will always gain 1 electron and have a 1- charge. Now, you may be wondering, well, where's group 4A? Good question. Well, here's the thing. Most of the time, group 4A elements do not lose or gain electrons. They usually covalently bond. So we don't really look at them so much in terms of ionic bonding and losing and gaining of electrons. But if they did, it would depend on the situation. So it could be a +or- 4 charge. Alrighty, so if we look at our periodic table, this is what we just discussed. So all of your group 1 elements or your alkali metals will always have a +1 charge. All of your group 2 alkaline earth metals are losing 2 electrons, so they'll have a 2+ charge. Now, we say boron group or family. Really and truly, we're looking at aluminum mainly, and then all the other guys in group 3A having a 3+ charge because they're losing 3 electrons. So they have 3 more positives protons than they do electrons at this point. Group 4A, we talked about this. They usually covalently bond, but in the event that there is an ionic bond going on, it just depends. They can either be a + or- 4 charge. And then group 5A, right here, the nitrogen group, those will be gaining 3 electrons, so they'll be a 3- charge. Your oxygen group will be gaining 2 electrons, so they will have a 2- charge. And then your halogens, group 7A, will be gaining 1 electron, so they will have a -1 charge. Now realize your noble gases over here, group 8A, those guys don't bond, right? They are noble, they are full and happy, content, outer energy level. So they're not going to lose or gain electrons. They have no charge. So all this is telling us right here is that your noble gases do not form ions, hey! And that group 4 rarely forms ions because they usually share their electrons, which is what I've told you already on the last 2 slides. So for that reason, we don't really look at group 4A, and we don't look at the noble gases for making ionic compounds. So what causes a charge for each group on the periodic table? Well, I've mentioned this maybe 2 or 3 times already, but let's look again. It's that the charges tell you how many electrons have either been lost or gained by that atom. So if it loses 2 electrons, now your protons will outnumber the electrons by 2, therefore leaving it with a 2+ charge. If it gains 2 electrons, now your electrons outnumber your protons, so therefore you have a -2 charge. Remembering always that electrons are negative and protons are positive. All right, so you've heard me say 8 in the outer energy level, 8 electrons. This is the oct, because 8 means oct. Oct means 8. The octet rule, and when elements have 8 valence electrons in its outer energy level, they are happy and stable. So that's why it says stability here. So this is where the noble gases already are. Every other element on the periodic table is trying to get to 8. So that's why it says the goal of an atom is to become stable. So it will lose or gain bonding with other elements to get to 8 valence electrons. So they might have to lose a couple to have a full outer energy level, or they might have to gain a couple to attain a full outer energy level. But either way, they're trying to get to 8 so that they can be stable and happy and complete. Anyway, that's about it for that. All right, so to reiterate yet one more time, looking at this atom of potassium, potassium has this one little outer electron right there. See him? And so if potassium loses that little guy, then look at its next ring, which will become its outer ring. It will have 1, 2, 3, 4, 5, 6, 7, 8. Aha! 8 electrons. That's what it wants. It wants 8 electrons in its outer energy level. So once it loses this guy right here, it's going to become happy and stable. So loses an electron, protons outnumber the electrons by 1, so the potassium gets a 1+ charge because electrons are negative and we lost 1. All right, so some examples here. Let's look at the periodic table to determine what these guys' charges will be. So oxygen, where is oxygen? Oxygen's in group 6A, which means it's going to take in 2 electrons. So that means electrons will outnumber the protons, so we will have a 2- charge. Correctamundo. Now, let's look at phosphorus. Phosphorus is in group 5A on the periodic table, so that means phosphorus will take in 3 electrons, and we will have electrons outnumbering the protons by 3, so we will have a 3- charge. Looking at fluorine, fluorine is our little floozy up in the halogen corner. And so being in group 7A, the halogens bring in 1 electron. So fluorine will have a 1- charge. Sodium, sodium's a metal. And it is over there in group 1A. So it'll lose 1 electron. Protons are now outnumbering the electrons. So we have a 1+ charge for sodium. Take a step over to the next column, column 2, the alkaline earth metals. These guys lose 2 electrons, so we will have a 2+ charge. Aluminum is in group 3A, so it's going to lose 3 electrons to take on a 3 plus charge. And then strontium. Strontium's back in the same group or family as magnesium, so it will take on a 2 plus charge as well. Notice something right here, guys. Notice this. Remember we said that our metals will become cations, and indeed they all did. And that our non-metals will become our anions, and truly they all did. So yay, we did it right. All right, now, the transition metals, the guys in the middle of the periodic table, the D block, if you remember back that far, these guys don't play so nicely by the rules. They can give you a headache from time to time because here's the thing. They have more than one ion. I know what you're thinking. Oh my goodness. But here's the thing. You only have to learn 2 of them. Yay! So here's the situation. They really can be stable by losing different numbers of electrons, and we're not going to go into all that, so don't worry there. But you really do have to memorize the 2 possible ions that these transition metals can make. And we will give you the ion chart. You can make little flip cards for memorizing them, and you can even get bonus points. What? Yay, win-win. Now, I know what you're thinking. You're going to have to learn 2 charges for these transition metals. It'll be okay. You'll get it. Here's the thing. There are a couple of exceptions, okay? There are 3 transition metals that only have 1 charge. So this is good news, right? So looking at these guys, zinc and cadmium, always and forever will be a 2 plus charge. Always. Yay. 1 charge for these 2 transition metals. Zinc and cadmium, always 2 plus. Silver, which is Ag on the periodic table, don't get fooled, okay? Silver will always and forever be a 1 plus. So make sure you mark this down somewhere, highlight it, circle it, star it, bold it. Know these 3 exceptions to the transition metals. So here we go. It says, what is the formula for the following transition metals as ions? Well, I actually have to tell you, this is the easy part for transition metals because you see these things in parentheses? Those are called Roman numerals, all right? And the Roman numerals tell us the charge. Yes, they tell us the charge for these transition metals right here. So half the work is done for you. You just have to make sure you can read a periodic table and put the correct symbol for these elements. So copper 1, because that little stick in the parentheses is a Roman numeral 1. So copper 1, copper off the periodic table. Don't you dare tell me CO because that's not right. Copper is Cu. And the 1 tells me it is a 1 plus charge. So that's literally it. Cu 1 plus. All right. Now let's go to iron. Iron 3, because there's 3 little Roman numerals there. Iron is Fe off the periodic table, and it is going to be a 3 plus. Now, some genius out there in the crowd tell me, how in the world do you know that it's a positive and not a negative? Well, hello. All we've been talking about all day is how metals make cations. All of these guys are metals. They are transition metals. So they all have positive charges. They're all cations, okay? So let's look. Lead. Lead off the periodic table, maybe you found it already, is Pb. I know, not even close to Lead, but Pb. And it's got a 2, so it's Pb 2 plus. And then manganese. Don't get this confused with magnesium. It's manganese. It is Mn on the periodic table, and there's 3 Roman numerals, so it's a 3 plus. Easy peasy apple squeezy. Okay, now there's another little exception to the rule, but it's okay. Just make sure you highlight it, underline it, circle it, star it, whatever. Mercury, all right? Mercury is a little bit different. So what we have to know about mercury is that mercury 1 ion is unique. It only exists as a pair, kind of like the diatomic elements, okay? So for mercury, which is Hg on the periodic table, mercury 1 is actually Hg2. Like I said, it's kind of like the diatomics. Hg2 with a 2+ charge. So this is one we don't see very often, but you just kind of need to plug into memory, or at least remember that there's something different about it. All right, so let's do a little check ourselves quiz here before we end our day. See if you've been paying attention, all right? So sodium. Sodium is in group 1A, so sodium symbol is Na, and it is a 1+ charge. All right, now you will never see chromus, but I'll tell you what it is. It's chromium. Ooh, I'm having a hard time writing here. Let's start this over. Chromium. Try this again. This little machine's not wanting to work with me. Chromium 2. So if I told you chromium 2, then you could easily tell me that it is Cr 2+. All right, now selenide. Here's the telltale sign on this. This ide tells me it's a nonmetal, so I'm going to look over in 6A, group 6A, and see that selenium is going to gain 2 electrons, so it's going to be a 2- charge. And then last but not least is tin, and tin symbol off the periodic table is Sn, and it's tin-4. Haha, no, tin-4 rubber ducky. Tin's going to have a 4+ charge. All right, guys, I know it was a lot to absorb today. Hopefully not too bad. I hope y'all have a great rest of the day, and we will see you later.